Hello, hello. Hello, hello. Yeah, let me set this thing up. Welcome to the third week, guys. Let me also share my screen. Hello, hello. Let me. I put some music on the background. Just let me know, guys, if it's too loud or too quiet, or if I should disable it. Because 1 week or 2 weeks ago, I added music, and then I it was only once, and I looked at the stream, and it was a bit louder than I would have liked it to be. I guess I'll just stop the music, and I'll enable it at the end when we'll have 1 hour of, I call it co-working, but since this is or remote, um, yeah, I'll be working on. We'll see. You'll see. Basically, let me stop the music now. Okay. Yeah, so I changed some things in the curriculum as well, but it won't impact you since it's in the future. Um, yeah, previously we had some other other order. Yeah, so let's see. So sound is all right. Okay. Uh, so day one of current week, we'll do these things. Finest machines, cinemachine, which is a camera tool. Some debugging examples. We'll talk about what project you would create. And yeah, 1 hour of co-working, which will be, so I will work on my own stuff and you on your stuff, right? But this comes like precedes the next 3 days. So D4, D3, D5, 4, where I'll be live coding a game from zero to published, hopefully published in the sense that at least on GitHub WebGL, so you can write a URL in your browser and you can play it right there. And I also try to launch it on some other platform. We'll see. There's also itch.io. That's another platform which is free. But yeah, we'll see. And we'll talk about launching an actual uh, game like right after in day 5. Yeah, on various platforms. Yeah, and this would be the Duck Invaders that for which I've presented you the GDD, the game design document at the beginning of the course. And yeah, it will be a simplified version of that. I will see what I can do in 3 days. It will be maybe 2 to 3 to maybe 4 hours uh, per day. And basically, you can watch me just start a new project and get the uh, get the game at the end of those 3 days. Yeah, and I'll go first in the I'll go through the game design document. I'll create a minimal version of it, so a subset of those things there, and that's what I will do today at the end. And yeah, the starting tomorrow, I'll actually code it. Yeah, on day 5 of this week, we'll talk about workflow. How will you generally start a project, depending on whether you're in a company or if you're a freelancer or if you're an indie developer, and if the project is big, small, and so on. We'll talk about building for iOS, Android, and so on, publishing as well. And again, co-working, and again, D6 would be an optional open seminar, which you guys didn't request until now. So um, just yeah, I know maybe it feels like working, so maybe that's why. Yeah, so just make. I mean, I'd recommend you to take advantage of this thing that I'm available on. I'm available on Saturdays as well for an hour or 2 hours. Yeah. Anyway, and week 4 we'll talk about your profile and your GitHub page and how to enter into foreign communities and so on. How to build your resume. Then working as a freelancer, so more in depth on this thing here. And on D3, we'll do some very simple interview simulation, and we'll do if this was a real like in-person course, you could have engaged. But yeah, I will just do a simulation, which I will answer the questions. I will ask and answer them, and uh, in all of these days, we'll have 1 hour of co-working, which I adapted it so that because this is remote and um, yeah, this is remote, so it's not. I won't be there to stay like 2 or 3 hours with you, but I will just be here available for you. And yeah, if you're working on your own project, then I'll be there to just engage. So you can unmute yourself in that moment. Just talk about anything. Just don't worry. Like yeah. So it's in all of these 4 days. And yeah, again on day 4 we talk about more about the social aspect of becoming a game developer, or really any developer, but game developer. So yeah, company conventions and just stuff that I've learned. Then on day 5 we'd have a skill exam, and we'll have to confirm today, or or these days. Yeah, who will be participating, and project grading and some feedback and so on. And again, on day 6, we'd have an open seminar, which is optional, and we can talk about rockstart.ai if you're interested in becoming a teacher, whether now or after 2 or 3 years. Yeah, good. So this is first day of the 3rd week. All right, let's see. This is my thumbnail there. Okay. Good. So we'll be talking about the finite state machines. And I don't have too many slides here because most of the content is in the repo. Let me see if I push the code. Yeah, and I've pushed it in the main branch, so you can check it in the main branch. Yeah, so what are finite state machines? They are, one second, so I can put this thing here. So they're a better way of managing complex systems. So think programming NPCs, non-player controllable characters, right? So basically the other players in a game, players that are not, characters that are not controlled by a player, right? So if you go in an RPG and you have people there that are coming to you and ask you for help and whatever, right? Part of the story. That's an NPC. A weather system, a wave system for tower defense game, right? Battle system. So anything that kind of needs more than 2 states, and or maybe more than 3 states. Yeah, if you see yourself writing a lot of if else and a lot of if that, like 3 or 4 levels of nesting, and it's around an object that behaves differently depending on its current state, then you definitely have to use this thing. And it's also has it largely overlaps with the state pattern that we talked about the last week. So the state pattern is basically, if you have your coffee machine, it can have a few very specific states, like waiting for money, then preparing coffee, then waiting for the coffee to be taken away, and yeah, you can say that 3 states are enough to describe it, and at a simplistic level. And the way we model that is we create classes that represent those states, and each class can have an arbitrarily large or complex logic in it. But at the higher level, we always have a current state, so a variable that stores the current state. And yeah, basically, the coffee machine stores its current state and calls some methods on it. And when that state decides to advance to the next state, then there are multiple ways in which you can do that. But basically, you change the next state, and the next state executes the code, and so on. Classically, a lot of programmers, no matter the skill level, it's not really about the skill level. It's about just knowing about this thing. So yeah, what I wanted to say, like classically, people would just use enums, and I used those extensively, and they are really good now as well. It really depends on how complex your states are and how you want to manage them. Um, So you do like a switch, and we didn't talk about switches if I remember correctly, but let me show you. So this is the switch. So yeah, so switch expression. So instead of doing an if they equals 1, do something else. If they equals 2, do something else. You do this thing like switch, and they and case 1, when it's 1, we write something or whatever. You can have a lot of stuff here, calling methods and so on. Yeah, and that's basically a switch. So that's how you do a finite state machine on FSM, right? That's the simplest way in which you can do it, and it works really well. Like if the high level view of it is more important, like seeing it here like this is more important than separating functionality in their own class, perhaps maybe because these things are very very simple. So yeah, you should prefer this way, right? But generally, um the way you do it, you would have a complete class, so a whole class that represents a state. And for example, in Unity, like depending on your game's complexity, you can have a lot of, so the states can have a lot of methods that you call on them. For example, on enter, on exit, update, which ties in with Unity's own update method. So like each state is its own um, bundle of functionality that only happens in a specific, like you can also see it like in steps. If you have like a coffee machine has 3 defined steps with 3, like they are in chronological order, but it doesn't necessarily need to be like that. So you can go from state 3 to state 1 and so on in these things. So yeah, these are the finite state machines. And yeah, this thing I stole the thumbnail from this guy's YouTube channel, so go and give him a like or something. And he talks about, I'm pasting the link here. Yeah, he talks about state machines more in depth. Um, yeah, a better way to code your character in Unity, finite state machine. And it's not about structure or the formal uh, shape of how you make it. It's just a conceptual thing. That means that make your create your states as classes, right? So create your states as classes where you can have an arbitrarily large or complex logic inside there, and dependencies and so on and so forth. Um, yeah, so just do it that way, and everybody does it differently. So if you look at 10 tutorials, 10 tutorials do it differently, but they follow the same principle. And if you like go to the purist side and like do go to a pure C sharp tutorial, you'll get like, it will get really confusing because it will take you a few hours to understand how you sorry, how you the general concept, until you can actually add your own logic, like player moving, player attacking, and so on, right? Yeah, so don't do this. Like this is um a method to be called when you want your character to start walking, I guess, or something like that, right? And you have a lot of these checks here, like if it's not swimming and it's not attacking and it's not dashing and it's not dodge rolling and it's not dashing again. This is just a mistake. If it's not jumping, then move player. this is okay. Like even if you have like 1, 2, then it's kind of in the gray area. Then you have the third one, you're definitely in the red area. You shouldn't do this. Sometimes it makes sense when this is the only part that's complex, and you have like 5 other places which are like if it's not swimming or whatever, and you have only in one part you have this thing, then it's fine. Just don't try to preemptively create a state machine. Um, Usually it's for more advanced cases, but you can see that even an enemy who patrols and attacks us when we are in range, um, there are something enough things to take care of, that you would need to turn the states, uh, first create the states and then turn them into classes, because yeah, this is how it's done usually. And in web development, in everywhere, like you have a lot of booleans, and it's a mess basically, because they're not mutually exclusive. So if you have 10 booleans, you have 2 to the power of 10 possibilities. So 1024, I think, possibilities. But probably 80% of those possibilities are impossible, actually. They cannot happen. So you're sometimes asking yourself, okay, if I'm not swimming, is it possible that I'm dashing? Oh no, because if I'm not swimming, I'm definitely not dashing. So you won't need to check this, but it's a mess, right? But you have concrete states. You define, okay, my coffee machine can only be in money grabbing state, coffee making state, or waiting for coffee to be taken state. Only those 3 states. So you have 3 possible values for your state. Whereas if you would have had 3 bulls, you would check, okay, um, is taking money or is not taking money, then is making coffee or is not making coffee, and so on. You have 6 states, and it's basically making it complex where it shouldn't. It doesn't need to be complex, right? So that's how you create complex game, which people look at them and they think you're smart or something, but you're just using simple ways, right? Just using the simple tools. Good. So yeah, let's make an enemy who patrols in like three three positions, 3 targets. He's doing his jobs, and when we move closer to them, they attack us. And the states are patrolling, which is sub-finite state machine which moves between 2 points. And in our case, it's 3 points. But you might be scared because I added this thing sub FSM. But generally, your state can be infinitely complex. So if this whole thing is a finite state machine, um, any other state can be its own finite state machine, which at a higher level you don't even care. You just say, okay, patrolling, it's your turn. You're the active state. Do your thing. I will be calling the on enable in our case, because we're leveraging Unity's own stuff, which is a cool thing. On enable, then update, and then on disable. I'll be calling these things for you. Um, and yeah, it's doing its job. We don't care, which means it can have a sub FSM, right? Then yeah, we'll talk about this later. But at a higher level, we have an enemy, which can be in the patrolling state, in the engaging state when they have spotted us and they are moving towards us, and then when they are in range for attacking, they will attack us. And when we just run run from it, and enough distance, that there's enough distance between us, the enemy will disengage. It will resume the patrolling sub FSM. And this is really cool. Like I really like this. It's a very, it's one of those things which are not that hard to understand. But if you try to understand the first principles behind it with states and everything, like you can apply it to everything. You can apply it to I don't know, a very, very complex system. And yeah, let's see. Ah, okay. Let me fix this thing. Yeah, so I can just delete this thing. Yeah, so let's do this. Let's go to Unity. So I can show you the end result, and I should have done this in other in other lessons as well, in other sessions, because it's better to see the end result and then look into how it's made, and then again see the end result. Okay, 1 second. Let me start the backup recording. Okay. Good. So this is the enemy, and I gave the enemy the some form of face, some form of face. Okay. And this is ourselves. Ah, I know what happens. 1 second. Don't need to care about this now, but because it was getting stuck in those things. I basically just because I'm doing just I'm checking the distance manually. There's no like collision or something like that. That's from Unity, and the like target touch distance is it's 1. So if it's 1 meter, if the distance between them is less than 1 meter, then it goes to the next. And you see, I mean, I will show you afterwards, but let me show you the end result. So we go here, and tries to, and it can follow us a very long way, because the way it works, if we are in range, they will try to engage with us, and they also we add some force. Yeah, it's nice. Yeah, and I mean, you can make this as complex as you want, with sound and with health bars and so on and so forth. And you see, it resumes its work. So if it was like if it was going towards that target, it doesn't forget the target, right? It always goes to whatever target it had, and we can also push it. Yeah. Yeah, and basically this is the enemy, and the FSM is just, there's nothing visual about it. It's just empty game objects which represent state, and when a state is active, it's the only one enabled. So not, yeah, active in terms of game objects, because you activate and deactivate game objects, and you enable, disable components. Yeah, and the cube, it's is like, yeah, enemy's mouse or something, or the gun, and the ground, and the enemy patrol points, which are just some capsules which I've turned into narrow things, which are trees. Yeah. And yeah, the enemy has no script anything on it, because the FSM controls it. This is like the brain. And yeah, each state has uh, dependencies. For example, the patrolling state has the points where it has to patrol between, so you can like arrange them if you want a different order. The speed of patrolling then the distance between each between the point and the enemy, which is where you should consider that okay, it touched it. Then the engaging state. So engage range is 15 meters, and this is the move speed. So when it's engaging, it's faster, right? So it's more realistic. So speed, patrolling speed is the lowest speed. Engaging speed is the highest speed. Then attacking, because it stays still. An attack range is 3 meters, so it tries to come to exactly 3 meters. So close to us, 3 meters. Then this is the shooting prefab, which is a particle system. We've made particle systems. You see, play. And yeah, you have to tweak parameters here. I don't have time for this to show you probably, but there are a lot of parameters here. Like the most important one is this simulation speed, right? So if you don't turn this into like 10, it won't work. But there's also like duration, starting speed, shape, right? Because you can have a bigger angle, you can have a higher radius, and so on, right? But basically we get this effect, right? Yeah, good. Attacking, okay, then disengaging, which just brings brings the enemy back to their next target. And the disengage speed is just a different one, so it's higher than the patrolling speed, because it's, yeah, they just finished the battle and they still have some energy, right? And they are like 5.5. If you wanted to be like fully minimalistic, you could just have this tree, and after attacking, you just resume the patrolling state, right? But I need this thing, like maybe you can, I mean, you can add an as complex as you want, a state that as complex as you want, right? Yeah, and the player is just a player with we've put the main camera on it. So when the player moves, the camera moves. And it has a simple player controller, which accesses its rigid body. In start and on fixed update, we move based on this thing which we've done the previous week, where we get the horizontal and the vertical input, which means it also works with joysticks and so on. Yeah, and we add force, and just we make sure to not go over a certain velocity. We don't want to, because we want to keep this move speed. So if the move speed is 5, we are accelerating. This is how you accelerate, one way of doing it, using physics instead of manually setting the position. And since you are constantly adding force, you have to limit the velocity, because what force does, basically, it changes the velocity. Yeah, and this is how you limit the size of a vector. So the velocity is a vector, and it can be like 5 meters, 10 meters, which means you move in a specific direction by 5 meters per second or something like that. But if this is 3 meters, you clamp the magnitude. So clamp, imagine like you're cutting it with some scissors, right? And you clamp it to this. You see, it takes a vector and a max length, and we clamp it by move speed. So this is how you limit the speed. I just want to take care of this, so I'm throwing it on the side for now, because states are more important. So let's look into states. Let's look into states here. Good. So this is the code. Actually, this. So we have an enemy FSM. So like I said, there are multiple ways in which you can do that, and the final state machine, it's not really like, Yeah, you can call it a pattern, of course. The more generic pattern is just the state pattern in C# or whatever language you want in programming. Um, and yeah, a finite state machine has a lot of overlap of functionality. But yeah, let's say like in games, you would use this term, like you'll create an FSM which represents, you might say, like the brain of an entity or the logic of a system's logic, or yeah, like I said, the weather system or like the coffee machine system. um yeah, and it's not always needed, and you don't always have to call it FSM, because FSM is only for when you have concrete discrete states, um 3 or more states, let's say, and they maybe change often. um yeah, like you want to change them independently, so you want, okay, when the player is moving, you want some sound to be played, you want sorry, you want I don't know, some fireworks to show, and yeah, it grows more complex over time. And yeah, that's how you do it. And in Unity has this nice thing which it calls stuff for us. For example, Unity calls on enable. Actually, let me put this thing here because it's more. First on enable, then update, and then on disable. Um, yeah, so in C#, for example, you have to create these things yourself, and when you change the state, I will explain all of this. Just don't worry. When you change the state, you have to manually call on enable on disable on the current state, and then on enable to the new state, and then manually have like a timer object which you instantiate, and you tell it, okay, call this update once every whatever. But since we're inheriting from mono behavior, Unity calls these for us. So if you remember from last week, enable when the object is enabled or created, um, update once per frame, and on disable when you disable the object or before you destroy it, basically. And I will tell what this is if you don't remember, or if you don't, I haven't talked about too much about the protected flag, or if you're a beginner. So yeah, we have the states: patrolling, engaging, attacking, disengaging. And then we have this enemy FSM, enemy state, and enemy states. State is just a kind of a container for all of those states. Yeah, so the enemy FSM is a mono behavior, and it has it exposes this, which is almost like a structure, in the sense that it just gathers some data. Not gathers, but it holds all of the states. So the enemy state, which is this thing here, is a class which its purpose is to hold the states. So it's nicely here in the same place, and you see all of the states, right? It exposes them like this, public, whatever, and you can see them in inspector. But since this is not a mono behavior, you cannot attach this thing to a game object, right? You attach the enemy FSM, which exposes an instance of this enemy states, and Unity creates the instance for you at runtime. You just have to expose it like this here. And what it does is it has this helper method. So when the FSM is ready, it calls this method on the states with itself, with the FSM. and it goes through all four of them. And of course, you have to make sure, like if you're creating another state here, you have to also add it here. There are better ways for doing this, but yeah, it's for now it's good. And it goes through each of them and it sets the FSM. So it passes the FSM to the states. This we will go through this afterwards. And yeah, what it does, it just stores it here locally inside. So each state will have a reference to the FSM itself. Okay, and then it disables them. So by default, all of the states are disabled. And there are better ways in which you can do this, because now that I think about it, its enable will be called. So actually, I mean, the code cannot do anything there. You have to just start them as disabled like this, right? So as deactivated. So yeah, that's a good thing that I've discovered now. Yeah. So your states start as disabled, and yeah, I mean, I'm disabling them here, but I'm also you have to disable them in you have to disable them in the scene. And in theory, like, you shouldn't need this basically, but for the sake of completeness, let's do it. Good. So this is the enemy states, and we add this thing here so it can be shown in inspector if a mono behavior declares it, like this enemy FSM, right? So even though you declare it here, if you don't add this thing, it won't be, you cannot show it. Good, then this is the enemy FSM. It has a reference to the enemy itself, which is just we only getting the transform component of it, because that's the only thing we are interested in, and the player, right? Also the transform component of it, because we only interested um in the positions. So in their positions and in their rotations. So we can also like rotate the enemy. You saw it rotates when you move it from 3 to 3. And this is how it looks. So we have the enemy, which is the enemy. And you see this is the symbol for the transform, this thing, right? So it's this thing, right? Okay, and the player. So we will know the states, and the FSM actually will always know the positions of the enemy and the player. And these are private, because if you don't write public here, it's private. So in order for the states to access the enemy and the player, let's see, do they really use this? Yeah. In order for the states to access the enemy and the player, we're exposing them here. So this is just a getter. So you cannot set the value. You only set it in the inspector. So you cannot do like, you cannot set the value, because it's read only. It's read only. Okay, and that's good. That's what you want. You want encapsulation. So you have your states can access all of the states. So each state can know its neighbors, so to speak. They can access the enemy through this property, then access the player through this state, and they can change the state, which is the most important thing, right? So when the enemy FSM starts, it initializes all the states, which does this thing that I described earlier. And then it enters the patrol state. Actually, can just do that. So changing the state, what does that mean? So you need a reference to the FSM, and you call change state, and you give it the state that you want to change, to switch to, right? And if you have a reference to the FSM, you obviously have now a reference to the states as well, because you write fsm.states, and then fsm.states dot whatever state you want to enter in. And that's the parameter that you are sending here. And yeah, we're if the current state is not null, and this is only true at the beginning, if it's null only at the beginning, we disable the current state, okay? And the moment we disable the state, onDisable will be called for us. And if the enemy state has any logic to be put here, like, I don't know, release some resources or something like that, it will do that there. Then we set this state so we can keep track of it. And then we enable this newer state. And if you make it so that this is the only place that changes the state, so nobody else enables or disables your state objects, nor it changes this thing, this should be consistent, right? You would never have two states that are enabled at the same time, or when there's no state that's enabled, except just at the beginning, right? Because this will be null at the beginning. And yeah, let's look at this enemy state, which is an abstract class. And what an abstract class means is you cannot do this. Cannot create an instance of abstract, right? Good. And the way we do, the reason we do this is because we want to have a base functionality for our states, but we don't care, like, we have some base functionality, but the actual functionality for each state, like the specific functionality of each state is inside a separate class, right? And they are all inheriting from this enemy state. And since enemy state inherits from our behavior, you can attach these things to game objects, like here, right? So all of these patrolling, engaging, whatever, they have a script on them. And you're basically working with Unity here, so you're like Unity's friend, right? You don't try to make everything in code like I was trying in my first years of Unity programming. You have to play nice with Unity, right? So it makes a lot of sense. So if you are in state patrolling, you activate this game object. And this game object can have like 100 mono behaviors. Here it can be a whole game, mini game, or whatever. You can have like an arbitrarily large complexity there. Yeah, and where is it? This is the base state, and this one gives you some just some shortcuts in your own states. So remember when we initialize states, we set this FSM. Here at the start, we do states.initAll, and this thing just goes through all the states and sets the FSM. So they will all have a reference to their parent brain in a way, right? Or whoever controls them. Or yeah, they kind of control themselves. It's like democracy in a way, or I don't know, maybe anarchy. Yeah. Yeah, and this, and of course these are Unity's standard on enable, on update, on disable, and yeah, these are the most important parts. And to make the the states which inherit from the base state, just write less code. Instead of writing like fsm.player or fsm.states or fsm.change_state, you're just creating a shortcut for them. So you can see here in attacking state, I'm just doing change state, right? I'm not doing like fsm.change state because it's not necessary, right? And you want to create the shortcuts like this. Just try to write as less code as possible to do the same thing, right? Just a guideline, right? Don't go to the extreme, but it's a good guideline. Yeah, in this shortcut, and instead of writing fsm.enemy, I'm just simply writing enemy, right? So in the attacking state, in the show the shot, which is we instantiate the particle system and destroying it after 300 milliseconds. We do enemy dot rotation, so we can rotate the particle system in the same direction the enemy is looking at. Yeah, so it's just a nice thing to just write the thing directly instead of fsm dot the thing. And let me tell you about this protected. So if you're an absolute beginner, protected means basically this thing can be seen by the inheritors of this class, but not by anyone else. So if you have, for example, or something, which is always one. Let's go somewhere here. So imagine you have like a state, and you can see the something here, right? So you basically see this one, but you cannot access this state. It's inaccessible due to its protection level, right? So this enemy or states protected means only inheritors of this class can see it, and inheritors are this attacking state, it's an enemy state, right? And you can see it. I don't know what I did here. State, this thing, you see, change state, states dot engaging. So this. So yeah, the inheritors can see the protect, and you can have methods like this protected, right? So you should give your members. So members are, remember, fields. This is a field. This is a property. This is a method or function, and yeah, they have protection levels, and you can by default it's private, or you can have them public, or you can have them protected. And it's good to give them the least amount of yeah, make sure they're as private as possible, right, for what you need. Good. So this is the enemy state. This is the base state, which all of the states inherit from. And let's start with the patrolling state. And this is actually the one that is a bit more, it has a bit more code because it does a bit more things. 1 second. It does a lot more things. So the patrolling state, yeah, you kind of have to make an effort here because we're starting with the most complex one. So the other ones are simpler. So I don't know, let's see. You know what? Let's start with the simple one. So let's say we're already in the, I mean, this is not, this is not simple. Engaging state. Yeah, this is simpler. So let's say like we are already running after the player, right? So we are already running after the player, which means this state is active like this, right? And we have an engaging speed and engage range. So 15 meters. And you see like these are some default values, but you can change them here for this instance of that mono behavior. Okay. And we are exposing this engage range because some other state needs it. So we expose it. We create just a property that returns it, right? And we're not using on enable and on disable because we don't need it. Yeah, we don't need it. So, but yeah, there's nowhere where I'm using these. Oh, actually, I mean, oh, okay, actually using it here. Okay, good. Yeah, so these are like when you enter the state, when you exit the state, right? So we are in engaging state, and what do we do here? So we take the time since the last frame, which is time.delta time. So it's usually like 0.03, let's say, or something like that. And we get the move speed, which is like meters per second. So we multiply it by how much time has passed, how many seconds have passed since the last update, and dist to move this frame. This will give us the distance as a floating point, so as a number. Then we get the player position, like this. So we have access to the player because the player is defined in the base class here, right? It's a property which returns whatever fsm.player returns, which is exposed in the inspector, right? Let's just go all the way, right? Here, player, bam. See, like I went like all the way to show the entire chain of, good. Then the enemy, the same, I won't do that again. And what are we doing? We are directly setting the position of the enemy, right? So which is a vector 3, so a vector of 3 coordinates. And this nice functionality, Unity's functionality, vector 3 move towards. What this does is it gets two vectors and a distance, and basically, for example, if this is at the origin 0, 0, 0, and this is at, I don't know, 0, 0, 10, let's take the simplest example, which means this is like 10 meters inside the screen, and this is like 3, it will return you 0, 0, 3. So basically, you have 2 points and you have a line starting, or a segment, better, a segment starting at the current and ending at the target. And let's say the maximum, like the distance between those 2 points is like 10, and the maximum distance delta is how much will you move from current to the target, like let's say 3. And then it will give you like a vector that represents like the point which how can I, this is quite simple, but I'll have to draw it, right? Yeah, basically not halfway, but let's say this is like 0.5, then you'll get a position that's halfway between these guys, right? So yeah, that's how it will work. Yeah, I'll have to create a new file, right, or something like that. File new. Is that how it works? Yeah. So you have one position. No, you have one position, and you have the other position. This is a vector with 3 elements, and this is the other one, and you have that maximum distance. So this is like from 0, and this is for 10, and if that thing is 3, then you will get then you'll get this vector basically. And in our case, we are looking for a position. So yeah, I just I drew it in terms of magnitude, but they are just in a coordinate system, like whatever, like something like this, right? And this is somewhere, and this is somewhere, but I know that the distance between them is 10, right? And if I'm if that third parameter is 3, I'm getting whatever vector has length 3 along this vector, right? And what I'm doing here is just like it moves the current position towards this position by this amount, right? And it says here, so calculate the position between the points specified by current and target, moving no farther than the distance specified by the third parameter, right? So we move the enemy position towards the player position by this amount, right? And that gives us a new position, and we assign it back to the enemy position. Remember, this is like the assignment. I don't know, this might be too basic, but yeah, for some of you, you might just want to see that again. Yeah, so we changed the enemy position, and then we make the enemy look at player. So this is a nice, very, very intuitive wording here. It's just perfect because they are transforms. Both are transforms, and the Unity's transform component, deals with the movement and all of that, and it has this look at. So you can look at another transform, or you can look at a specific point, like a vector 3 point. And we are doing this in other states as well. So when an enemy moves at a certain point, you want the enemy to also look at that point. Otherwise, it would look weird, like it goes sideways, right? And then we calculate the distance to the player, which it includes actually what we've done here. So if we move it towards the player, this enemy position would be different than it was like this line of code, let's say, at this moment. So the distance to the player, we get the distance between them. And if the distance is, if the distance is higher than the engage range, then we change the state to disengaging, right? And whatever that means, like this state shouldn't care what that means. It just knows that, okay, when I'm done, I should disengage. And return means we won't be executing whatever it's here, right? You could have done it like this, right? You can like or like this or whatever. Those, if it's only one statement, you can write it without the curly braces, and lots of people don't like that, but I'm fine with it. So yeah, you can do it like this. So if the distance to player is higher than the engage range, then do something else. If distance to player is smaller, is less than equal than the attack range, go to attacking again. So yeah, otherwise just do nothing. But I like it like this because it's I just like it like this. Okay, so if the distance to play, if basically the player is still in the engaging distance, we are still chasing the player not here, right? And if the distance to player is less or equal than the attack range, which is always smaller than the engage range, remember? So engage is the minimum distance from which we start moving towards the player, and the attack range is the minimum distance on which where we attack the player effectively, right? When we enter the attacking state, and that's what it does basically, the engaging state. So let's go now to the attacking state. So the attacking state has the attack range, which also exposes it here because the engaging state needs to know when to exit. One of the moments when to exit, whether to disengage or start attacking, right? And it says states.attacking.attack range, this thing, right? And we expose the attack range here and the shoot effect prefab, which we don't know what it is here. Let's say we don't know what it is, and we only know we have to instantiate it. So game object that instantiated under the enemy transform. So it will be a child of the enemy. So if the enemy moves, like the bullet will move with it as well. Um, yeah, it's not like the best way of doing it, because if the enemy rotates, the bullet would just rotate like this with its if it's in the air. Um, so actually no, actually let's do it like this. Yeah, let's do it like this. And also let's set its position. Set position and rotation. This is a better way of doing it, because is actually what transform is a matrix behind the scenes. It's a matrix, and it represents position, scale, position, rotation, and scale. And what you're doing here, you're transferring that matrix directly with the position and the rotation. Because if you do position and then rotation separately, you do two calculations, not efficient. And it doesn't matter here, but it's good to know for later. Just good thing to know. If you want to change both of them, just change them like this: transform that set position and rotation. Yeah, so we are positioning the effect exactly at where the enemy is, and rotating it exactly so it goes in the same direction, the forward direction, which is the Z coordinate, which is the blue uh, arrow in the Unity scene. And we are not parroting it to the enemy, because we want, once the bullet is shot, then it shouldn't change its rotation or position based on where we are. It's just alone. Okay. No. So okay, I was this thing here, shoot effect prefab, and in the attacking one, it's this thing. So attack range is 3, so 3 meters. When we are 3 meters or below, we start attacking. And this is the shoot effect, like I showed you before. So this is how it will look. And if you see, like, only one, it only shoots once, but you see that the enemy shoots a lot of times like this, because like our attacking state is not like completely perfect production ready, because what it does is it constantly enters and exits that attacking state. I think, like, it gets to 3.1, then again 3, then 3.1, then again 3 really fast, right? And you see this thing here. Okay, let's change this thing. Yeah, and that's so this is the attacking state. Then we have some things here, like this is this is a thing that allows us to attack basically once per second. And yeah, this is actually constant, and we can write it like this, or uh or this, or I think I am still old-fashioned and do it like this, or attack cooldown. This is the way constants were written, like all caps. So if something is constant, it doesn't change. And yeah, I'm still using it like this. I don't know. Some people just want to write them like this. Okay. So once per second we attack, even if we are in the attacking range. And here is a variable that stores, okay, when did we attack last time? Okay, and let's see why I'm doing this. So last attack time was 1 second ago. I think I don't have to. Okay, so when we enter, the state, okay, this will be minus, and time plus whatever will be always greater than this. And yeah, I don't think we need this, actually. I don't think we need this. So don't worry about it. So yeah, in update, we look at the player again, and we check, okay. So what this field returns is the time since the game started, and it's in seconds, and it's with a floating point. Yeah, so 1 second. I just greeted you guys on YouTube. Yeah, so the number of seconds since the game started minus the last attack time, yeah, which is 0 at first, and then it gives you like, I don't know, 30 seconds or whatever. In 30 seconds, it's higher than 1, and then it goes here, right? And then it sets this thing. Last attack time would be this thing. And then it goes like the next frame here, and then you have like 0.03. Is it higher than 1? No. So it waits until 1 second, uh, until the 1 second mark since the last attack time, right? That's what it does here. And the attacking means these things. So show a shot, which we've already discussed, and we are also like destroying it. This is the way you destroy a game object. You see, the effect is an actual game object, so you shouldn't destroy the like components or stuff like that. You should destroy the game object itself. So when you instantiate this thing, it gives you a game object, and you can give it a t, which is um yeah, it specify, okay, after how many seconds should we destroy the object, right? So we instantiate the bullet, and after 0.3 seconds we destroy it. Very straightforward. um okay, and then apply shot force. So what this thing does is, okay, it calculates what's the vector from us to the player, or I mean from the enemy to the player. And the way you do that is you subtract it from the player position. So let's say you are in 1 dimension, and what should you do to the number 3 for it to reach number 5, for example, right? So you are 3 and you want to reach 5. So 3 is start and 5 is end. You basically do end minus start, and it gives you 2. And that's what you need to do to the number 3. You need to add it to, right? And it's the same thing and in any number of dimensions, right? So here we are in third dimension, right? So we have like 3 components for the position, x, y, z, for the player and for the enemy. And what do we want to do here? So we want we want to apply a force to the player that comes from the enemy, right? So we want to apply a vector that comes from the enemy to the player, and we basically subtract the enemy's position from the player position, right? We say, okay, where we want to go minus where we are now. Like I said, we want to go to number 5, and we are at number 3, and then we do 5 minus 3, right? And yeah, now you can work on 100 dimensions if you want. um, Good. We have that vector which represents the distance and the orientation in the same bundle. And then we get the direction for that, which is only, it just means the normalized vector. Basically, like the line along this vector, which is 1 meter, 1 meter long. And even if this vector is like in total like 0.1 meter long, this normalized turns it into 1 meter, basically giving us a direction. Okay. And then we hard coded the force amount, which is 2. We don't need to make everything configurable. And what we do, okay, we now have the vector force that we want to apply, right? We have the vector to the player, but we don't want to add a stronger force if the player is farther away or not. We are just using it to get the direction, right? And the actual force applied, it's always the same. It's 2 in this case. So it's like 2 meters or times whatever, how forces are displayed, or like kilograms times meters, I think, right? So something like that. But yeah, the force is 2 and the direction is this, and then we get the vector force. And then we get the player's rigid body component, and then we add that force to it, basically. So the force again describes the direction and the magnitude of that direction, right? So this means how strong it is, and this means in what direction should it be. And we chose the force mode impulse so that it's instant. And what impulse does, it disregards mass, I think, or at an instant force impulse using its mass. Oh, okay, it doesn't disregard. But I think if it's force, which is the default one, um, it actually like it tries to combine with the current momentum of the object. So if the object is already moving in a direction and you add a force to it, it tries to combine them somehow. So it maybe like cancels them out or something like that. But if you use the impulse, I think it disregards the current forces and it just gives it an impulse in that direction. Yeah, so when you're in doubt, when doing programmatic force adding, just use impulse, and yeah, you can look at other modes if this doesn't work. Good, we apply the shot force, then we just write it in the console, and we store, okay, we have just attacked at this time, so it will know to skip it if it in the next immediate frame and until 1 second has passed. Then we see, okay, what's the distance between us and the player? And if the distance is higher than the attack range, it means we shouldn't attack anymore. And then we change the state to engaging, right? And even better, this should be, or shouldn't. Yeah, actually, no, it's good this way. And actually, if we want it to be like perfectly, if we wanted to be like to do it the right way, because physics are can this work? Yeah, can it work? Because always that's the beauty of having only one state active at any time. um these things won't overlap with another state's update or whatever. Hmm. Yeah, that's interesting. um I mean, if you disable it, it shouldn't. Yeah, no, yeah, it works because all of the states are disabled, and this one is enabled, and yeah, after you disable it, these things are not called anymore. So yeah, so we added this fixed update, if you remember, because physics has to uh, be done or called inside the fixed update. And let's go, where are we, in the state? Yeah. And actually, yeah, to be a good citizen, you'd have to call the basis functionality always, even though like we know that. I mean, let's actually turn them abstract into abstract, because we have them empty here, and let's not just add them here empty if we don't need them. So yeah, abstract means it doesn't have a body. We are providing a body. Whereas if you maybe want to do something here like debug.log, we are in the state, right? We are whatever, right? You'd have to call this right here, and then you do your stuff there. So that basis functionality is called first and yours second, and so on. But we don't need that, so we just keep it simple. They are just abstract methods, which we are. I know why I have did that. This I know why, because if they are abstract, you're forced to override them. But if they are just virtual, you are not forced to override them. Yeah, you're not forced to override them. Good. Okay, so we are in fixed update in the attacking state because we are doing this thing with apply shot force, which uses physics, add force. So yeah, we have to use fixed update. Good. So this is our attacking state. And after attacking state, we go into the disengaging state. And what this does, let's see what... yeah, initially, this was initially true. So when the enemy was disengaging, you could move closer to them and they will not they will not attack you. So it was an example of a different state, like a fourth state, where you come closer to the enemy, but they don't engage with you because they are in the disengaging state and maybe they are tired or something like that, right? And yeah, but I said, okay, maybe it's not. Uh, I mean, it's more realistic. In this case, I think it's more realistic. It's better to be more realistic than to be more educative. Yeah, educational. um, so yeah, even if they are in disengaging state and you move closer to them, they will still attack you. Good. So this is the disengage speed. I mean, at least the default value, because the actual value is 5.5 for that instance. And let's say we get the, if we are in disengaging state, it means we are just resuming what we were doing before engaging. So we get, because we have these states here in the base class. So in the base class, right? Because we inherit from it, so we inherit everything. We have access to these states, which references all of the states. And then we just pick into the patrol state and we look, okay, what was the current target? And it exposes it here, right? I mean, by the way, while you're implementing these things, you are exposing stuff because you need them, right? It's not that you are exposing them and then you say, okay, okay, well that's so nice that I'm exposing these things, this thing, let me use it. It's just the other way around. So you need it, and when you need it, you expose it, right? That's I don't know, it's obvious for some, but maybe not for all of you. Yeah, so we get the target, and then we look at it. The enemy looks at it. Then let's see. current patrol position is target dot position, so we get the position of the current target, and the distance to move this frame is disengage speed times how much time has passed since the last frame, delta time. Okay, distance to move this frame, and then we actually move, and we call this again move towards. So we move from the enemy position to the current patrol position by this amount of distance. Yeah, by this amount, and we basically get a new position which we assign to the enemy. And then we check, okay, is the distance from the enemy's position to the current patrol position less than, and then we again pick into the state here, which it yeah, it defeats that intimate inappropriate intimacy code smell, right? Because you should somehow have this you should do it some other way, right? Not like this, but it's fine for now. It's pretty simple. We just get the patrol state, and we get, okay, what's the target touch distance, which is this thing which tells you, okay, what distance, which is 1 meter, what distance should the enemy be, what distance should there be between the enemy and the tree for them to be considered touched, so that it will go to the next one, right? And the position is actually goes from here, from its center, so from here, right? No, not from its surface, right? From here. That's why, like, it has half meter here, and the tree has also 0.15 meters, and yeah, like I put, okay, 1 meter. Oh, and enemy also has this cube. And this cube also, like, it's like its nose, and it's hitting with hitting the nose, it's hitting the tree with the nose, and it says, okay, I'm not reaching it, so let's just remove the collider. We don't need the collider anyway, and it's actually a good thing to remove the collider if you don't want the nose to be hitting. And yeah, then I think we can make this even smaller, like where is it? Patrolling, we can make it like 0.8. Yeah, so we are getting that thing. So if the distance between the enemy and the current patrol position, target position, is smaller than whatever is needed for it to be considered touched, we change the state to patrol, right? And then we return, so we don't execute these things. And if it's not, so it's still just going towards the position. We also check, okay, we are still just going, we are going towards our target. Let's say if anything else happened. And we, for that, we check the distance to player again. So, okay, let's see the distance from the enemy position to the player position. And if this distance, which is a float, so it's a single number, if that distance is smaller than states.engaging, so we ask the engaging state, okay, what's the engage range, right? What's the range, the minimum range the player should be compared to the enemy, like their proximity, for me to change you as the state, right? So what's the engage range, right? Is this thing that we assign inspector, engaging range, 15 meters, right? So if the distance to player is smaller than 15 meters, I'm changing the state to you, to engaging state. So we are in the disengaging state, and okay, player, we now see the player again. Let's change again to engaging, right? And then we go to engaging, we went there, and okay, let's say we don't we don't come to attack the player because we were engaging, but they just run away too fast for us to enter the attacking state, and then again we disengage. And let's say we are reaching our our current target, and we change again the state to patrol. And now we can talk about the patrol, which is like the first state, but I wanted to let it as the last one because there's a bit more here to talk about. Yeah, so you can think of it as an FSM in itself, but it's so simple that I didn't even add like an FSM here or whatever. It's just too simple, right? You don't have to write always the same structure. Just depends on how complex things are. But it's pretty simple. The patrolling state has three reference to 3 points as their transforms, so we can also see them. And they are directly like this. They could even be like empty objects, right? They could be like empty objects. But yeah, just have some visual things. They are like trees, right? And we have their position. Okay. We have them here. So again, patrolling state, points, bam, 3 things, and you can add as many as you want. Here, points, you have the speed, the patrolling speed, which is 2 by default. If you do like reset, you get like 2 here, right? Control Z. Speed 4, target touching distance 0.8. And yeah, we're exposing the current target, but also we are using it here, which is a nice shortcut. So it just replaces this thing. So current target point, which is 0 by default, which means it's the first point because we are starting from 0 in programming, right? Yeah, so the current target will be like the first point, and the target touch distance this is just exposing this value for the outside world. And in update in patrolling state, what do we do? So we get the current target like this, enemy look at the target, so the enemy can look at any transformer, any vector tree, any position, right? Yeah. And then we get, okay, what's the target position? This is the target position. Then distance to travel this frame, so speed, okay, which is meters per second. And seconds since the last frame, right? Seconds since the last frame. And we get distance to travel this frame. And then we again do this thing. So vector 3 moves towards from the enemy position towards the target position by this amount. And we assign that to enemy position. And you see this state resembles this state quite a lot because they kind of do the same thing. So you theoretically would have to create like a enemy mover class which moves the player, right? Something like that. But just try to not reuse stuff and over apply the dry principle. Don't repeat yourself because it's not that bad. Like if you had like 100 lines of code, then probably you should have done that. Or if you had like in 3 places, then maybe yeah. But if it's just in 2 places, it's fine. Yeah, enemy position, then enemy. Yeah, we just store the enemy position like this in a variable. And we then check, okay, if the distance between the enemy position and target position is this, yeah, this value that represents, okay, what distance signifies that we have reached the target. Okay, so if the distance between the current target is smaller than the needed, the minimum necessary distance, then we switch to the next target. And the way you do that, you basically say, okay, current target is the current target plus 1, right? So from 0 to 1. But let's say we have 3 targets and we have 3 targets. So you should go from 0, 1, 2, then 0, 1, 2, then 0, 1, 2. So if this is 2 and we add 1 to it, it's 3, but we shouldn't have more than 2, right? And then we just do modulo how many points there are. So there are 3 points. So 3 modulo 3, it's 0, right? And again, for whoever doesn't know, modulo means the remainder for dividing 3 by 3. Division, like integer division. Like 4 divided by 3 is 1, remainder 1, right? And so on. It goes like a clock. It goes from 0 to 11, and then 12 is 0 actually. And then 0 to 11, and 12 is 0, and so on. Yeah, okay. And there's our current target point, right? And then we check, okay, if the distance to player, so from the enemy position to the player position, is smaller than the engage range. So again, we go to the states, we ask the engaging state, okay, what's the engage range below which I have to set you as the next state, right? And if the distance to player is smaller than that amount, then we change to the engaging state. And you see each state does its own thing, and it doesn't really know how the other states work. And it's nice separation of concerns and all of that. And you can have like 100 states, and you can have 100 states in any other state. Like you can have an FSM here inside where you do a lot of things, and yeah, you can get very complex if you want, and it will appear as if you're doing something really smart. But I mean, it is quite smart, but it's not as smart as it looks, because you're just using a well thought a system that's really scalable. And yeah, instead of doing like, if you remember that slide, right? That also looks pretty complex, but it's one of those things where it's complex without it needing to be complex. Yeah, and this is this is my attempt to explain this thing. Let's see it again in action. So engage, and they will just keep seeking us, reaching us, if we want. See, if we move too far away, then they will just, yeah. And they have a higher speed now, but now they will have a lower speed. Doesn't appear. Yeah. Yeah. Okay, somehow we've fixed that thing where it shot us multiple times. But we can do it like this. We can attack cooldown 0.2. It's more interesting like that. Yeah, anyway. So that's how it works. Yeah, and there's a third-party asset for a more visual approach, which is called Node Canvas. You won't need it right now, but it's good to keep in mind for later. Yeah, it might be appealing because visual stuff is nice usually, but yeah, I mean, depends on your free time. Like if you have a lot of time, and yeah, it's not free. Yeah, it's pretty nice. And what I'd recommend you is just try to do it the way I'm doing it here with states and all, right? Which it works amazingly well. Like they are like here and whatever. And what this thing does is just gives you a more visual way of seeing basically this thing. Like instead of seeing, okay, whatever thing is enabled, you just see, yeah, you'll see this thing, right? You'll see like, okay, this is the active one and so on. But um, this is like just, I don't know, 5% of the functionality, because it has a lot of other functionality for actually running your logic here. Like you can define variables and all of that, but like I'm not a big fan of visual programming. Like I find visual programming like a trap, in the sense that um, it's really nice at the beginning, but once you want to get something really complex, it's harder to debug and all of that. But I mean, yeah, a lot of people basically create games using maybe 90% just visual programming. Um, yeah, I just want to have all of the code there, and want to see the code. Okay, if that, then that, and if I'm working with more people, like I want to see, okay, exactly what I want to see the text version of the logic, right? What have they added and what have they removed and so on. Um, yeah, but maybe if you want, if you have like 8 states or whatever, 15 states in a bigger game, like I don't know, like a turn-based game or whatever, and you want to have a way to visually debug somehow, you can do that as well. But try to not. I mean, at least in my experience, I haven't looked too deep into this asset, but in my experience, it just makes sense to try to just use this functionality where you view what state you're in and so on and so forth. But um, I'm not over relying on a lot of events here and a lot of variables and a lot of stuff. Like I don't really like that, because if you have like a variable like, okay, is shooting or is, I don't know, is running, is swimming, it's basically the same thing as here, right? It's the same thing as is swimming, is attacking, is right. You will start to do those ifs, and it's basically the same thing, right? Um, but yeah, you can you can still use it, and I would recommend it in some cases, just for the visual part, if you want to visualize your states, right? Um, yeah, but if you don't have time, just don't look at it, right? Good. So these are the finite state machines. They are called finite because there's a finite amount of them, but yeah, the finite number of them. But it's not. You can just call them state machines. And we will do some cinemachine, a dive, not deep dive, but just a dive into cinemachine, which is just a tool for working with cameras. So you see, this is a camera, and this is how the guy looks in the camera. And yeah, you can do a lot of things. Like, I'm not an expert. There's also a Unity timeline. Unity timeline is a plugin for Unity, which is, I think it's like a default one. Probably not. It's not enabled by default, or maybe it is, but you can enable it, so it's not like a third-party asset. And with Unity timeline, you can actually just create movies or cutscenes in your game. Yeah, so a timeline is an asset that describes. It's very similar to the animator. But usually the animator and the animation, actually the animation asset in Unity, describes a very small unit of animation, like uh, moving your arm, right? Or jumping or whatever, right? But the timeline is just like a very big animation, and much more visual and optimized one for stuff like movies or cutscenes, right? And we won't be covering the timeline because I honestly don't know how to use it because I didn't use it. Um, Yeah, but I think it's a really cool thing. You can create, like I said, cutscenes in movies and probably other things with it. Simulations, yeah, like you can run like a weather simulation or something like that, but like you're doing it by hand, not like physics weather simulation. Um, yeah, and you see like the camera can move certain way and characters can move and whatever. But Cinemachine is actually, I think it was created for the timeline, or the timeline was created for it, or something like that. They're really tied together. Um, because yeah, you want to move a camera, but you don't want to think about like writing code to make the camera look in the certain direction and like to have some shaking or to have some damping, like to not be robotic, you know. Cinemachine does that. So Cinemachine moves and rotates cameras. Basically, that's what it does, and we will be doing that. Yeah. So this is how you import it. So we go to the package manager, and you go to Unity registry. Then you see I've already searched for it. Cinemachine. You write it here, and you see it here, and you press install. Good. So yeah, this is the folder for Cinemachine. Yeah, so here it's not that important, but you see I've created an assembly definition so that these things are compiled separately from these things. So when I'm changing a script, it's not compiling my whole project. It's only compiling whatever it's in the folder containing this assembly definition, right? ASM assembly definition. And again, you do it like this: create assembly definition. Good. And again, here as well, I'm creating assembly definition with this thing uh, for so I can create code. And yeah, basically here I will be showing you. There's not too many slides for this, but there is content here inside the. So yeah, import it. Yeah. So the way it works, you still have one camera, but there are virtual cameras. And they are simply objects that describe a camera's state, which is position, color overlay, rotation, and hundreds of other parameters, or tens, hundreds actually, I think. And switching between these states creates a smooth transition. Create a smooth, create smooth transitions. Yeah, and you can look at this thing more in depth if you want. I mean, I highly recommend you to go through these things. Not now, but after this. So you'll go through these things. Not all of them, just what you're interested in, because it's a big subject. Yeah, actually, let's remove this because it's on another slide. Yeah, and this is getting started. This is actually the simpler one. I'd actually recommend you enter here first. Cinemachine. Okay. And yeah, you can go here, getting started, core concepts, timeline. Yeah, they talk about timeline quite a lot, but you can do it like you don't need timeline for this. Setting, okay, basic, okay. Setting up multiple, okay, merge transition, yeah. And you can go directly here to samples and tutorials, and this is a good tutorial. Yeah, you see it's just 3 minutes, 4 minutes. I mean, it's just in maximum, maybe in an hour, you're done with it. But we'll be talking about demos, but not that in depth because I'm not an expert on this. I'm just doing like the 80-20 amount of effort, just so you can know it exists, and just so you won't be reinventing the wheel, so you know something already exists. Okay, let's take a look at the w3d1 examples in the repo. Yeah, so we'll be doing these things, and I don't think it matters if I'm just repeating these things because you don't know what they mean until unless you see them in action. But this is like the order. So let's do this. Like, look at simple, right? So look at simple. Yeah, well, first let me give you an intro on whatever scripts I've created. So we have the player controller no force, and it's not that important to understand it now, but you see, like, I'm exposing, okay, what's the move speed and what's the whether to lock the rotation to the camera, which means that when the camera moves around you, the character, you also move in that direction, like in GTA 3 or GTA Vice City, or where you move the camera and the player also moved with you, right? And I'm not doing a first person perspective now, only a third person perspective, but first person should be easy to do anyway. And this parameter controls that, and it's here in the lock rotation to camera. And for example, in this one we don't do that. Yeah, so in update we basically move each frame by an amount, so it's smooth, obviously. Yeah, and if we have this lock rotation to camera, what we do, we need the vector that describes the movement necessary from the camera towards us. And what do? We subtract the camera position from us, remember? So target minus origin, like ending point minus starting point gives us the vector that we have to add to the starting point to get to the target point. And what we do, we subtract we zero out the y component because we don't want to we don't want to change our orientation upwards or downwards, only on the xy or only on the xz plane, right? Basically the ground, because the y is up, which means that we don't want to look up or down. Basically, that's what we do here. So we remove any y component from this distance, and then we get a direction. Basically, we turn this vector, however big it is, into a normalized vector, so of length 1, and we assign the forward vector to our player, which means our forward, so the z coordinate, local coordinate, which is the forward one, where are we looking, will be now the same as this direction. So what that means is if the camera is behind us, we are looking like this, and if the camera goes to the right of us, we will look in that direction, and so on. That's what look rotation does. And of course, that's like a secondary functionality, because the main functionality of this thing is to move the player, and we do it like this. You remember? So we get the horizontal, vertical component, which also works for joysticks and so on. We get the movement per second. So we get like the horizontal changes our x sideways. So position, we don't move up or down. And the vertical movement changes our z position, so backwards or inwards. inside the screen or outside the screen. And we get this. So these things will give us, I think, this is a value from -1 to 1, and this is from a value again from -1 to 1. And we multiplied by the move speed, basically how much per second, right? And we have this thing here for safety, because we don't want to apply a very, very small amount. We say, okay, if the amount of speed, the amount of speed is less than 0.1 meters per second, we just don't apply it. We wait for it to grow bigger. Okay, and then we do again of how much time, how much should we move per frame, which means we multiply the per second with the how many seconds have passed since the last frame, and we get the move per second, per frame. And this is a thing that you have to, maybe not easy to understand, but basically what we're doing, we get the camera and we convert this vector, basically how much we should move per frame, into the camera's own coordinate system. And the reason for that is that we want us to move inwards in the screen if we press up arrow. But the global z vector doesn't move with us. Only our local z vector moves with us. So if, for example, we're aligned with the global z vector and we move slightly to the right, and the camera is behind us, basically when we press again to move inside the screen, we then want to move in that direction, right? We don't want to move to the global z. And what we do here, like we have this thing which like let's say we always press forward to move forward, and this will always be the vector 0 0 1. Basically the z component of it will be 1, but we don't want to move to the global z, right? Because if we move to the left, right, you're right, but if we move to the left and the camera is backwards, it's basically now the z becomes x actually, right? And basically what we do, we get to the camera and say, okay, camera, we know that you, the camera, you are basically looking towards whatever I'm seeing as the inside of the screen. So transform this thing for me, like give me the vector that's that represents movement inside towards the screen, right? In your local space, and that's what it does. So it gets a global vector and it transforms it to the local space of an object. And of course, for example, if the camera's scale is weird, it will also scale the vector and so on, right? And there's also like inverse transform vector, right? So that transforming something from local space to the world space. Yeah. And then we get like move per frame in camera space. And then we make sure we don't move to the Y position, because if the camera is up and we are down, maybe we get some weird Y movement as well, because we don't want to move up and down. And then we do this, like simply transform dot translate by this amount in the world space, which is equivalent to this thing. Position plus equals is the same thing, right? I mean, maybe it's better like this. Basically, we're adding this amount to the global position. I don't know, man. Let's do it like this. It's simpler. So yeah, we're adding this to the position. Yeah. Okay, then we look ahead. So we are moving, but we also want to change our orientation as well. So what we do, we get the same vector, we normalize it, so we get like the unit vector, and we align our forward direction with that vector. So it's the same. And that's what this player controller does. And it's called no force because it doesn't use physics, basically. Let's see, anything else to be... Okay, this is for later. Good. Let's look at this then. We have a player, so I've created a prefab for it because I'm using it in multiple scenes. So the player, let's take a look at the player. We can even double click it here. Has two eyes, which are cubes. Okay. And the player is just a capsule collider. I mean, a capsule with a capsule collider and with the script on it. And it has a move speed 5 by default. And lock rotation to camera false by default. And this look at simple has the player and has the ground. The ground is like the simplest object possible. It's a plane, right? Which you create like this, 3D object plane, bam. And then you scale it, whatever, like that. And you added some material and so on. And it's a prefab as well, right? Yeah, good. The way you start with the cinemachine, you add a cinemachine brain. That's what it's called. So this is the component. So you basically do, or you just brain, brain, bam, and you add it, right? And let's say, is there anything that I've changed? Yeah, I didn't change anything basically. So it's just the default one. So now your camera is a bit smarter, and then you create a virtual camera. So you see it added a new menu here, cinemachine, and you have a lot of things here that I don't know how they work. I just know the simple stuff. Virtual camera. This is the most used ones. And yeah, you call it, I mean, there's a lot of conventions, but you can call it like whatever you want, right? This is a virtual camera. And let's see what I did on the camera. So I have assigned it a follow object and a look at object. So we want to follow the player, right? And we want to look at the player. And let's see other stuff here. So yeah, on the body do nothing, which means we won't be moving the camera, right? So the body of the camera won't move, right? This one is it. I'm just switching between them. So to see what I've changed. So the body do nothing, which means the camera won't move, but at the aim, we use this composer mode, which, let's see, any changes there? I mean, let's add its stuff so it's aligned perfectly. Okay. Yeah, we changed. I mean, this thing can be just 0.5. Yeah, we changed these things. So I changed the dead zone width and the dead zone height. And what that does is, but I don't think you can see it. I don't think you can see it very well. It's these things here. You see? These things here. I just need to go to window, lightning, rendering, lighting, and environment. No, not that. Not that. Oh wait, that's the shadow. I mean, let's see if I do this. No. Yeah, I don't know how I can show you actually. Yeah, you can see them better now, but it's still. Yeah, there's these things here which are the safe zones, and there are some here as well. Maybe you're not seeing. Dead zone width. It's basically in this zone, the object can move, and the camera will not try to follow. the object, because it's considered that okay, it's enough to see it here. Okay, and that's also dead zone height. You can change it, right? And there's also soft zone. So it's kind of soft zone, I think, where you see it, this thing here. I think it's the part where the camera slowly tries to move towards the object, and when the object passes the safe zone, the soft zone, it tries to go really fast towards it. So it's a nice blend. Like it's not always fixed robotically on the object, right? Um, yeah, and I don't think I've changed anything else here. Yeah, let's disable this thing. Oh, this thing looks better. Oh, okay. I think maybe if there are multiple cameras somehow. Oh, I know why. This camera actually is the active one. That's why. Because when only one virtual camera can be active at any given point. And I mean, you can have multiple ones, but you have this priority. And actually, the camera which has the highest priority, it's decides the camera's properties and so on and so forth. And they are called VCams, but they're not actually cameras. They just change the position of this camera, right? But let's disable it. And yeah, they're here. They are here. So this is the soft zone, and this is the dead zone, or I don't know what it's called. But it's a zone where the camera tries to never have your object in, because it's like it goes into panic mode, like, whoa, I have to really reframe the object, right? So it moves itself, or it aims itself. And I think it works even now. Yeah, you see, it works like this. So it's nice that it works in edit mode as well. But yeah, so we have our player controller on our player. You see, I am using WSD and I'm moving like that. And this is the camera. You see, it looks after us. That's how it works. And you see, it's smooth. It's smooth using that soft zones, right? You see that those soft zones are making all the work. I mean, all the work, but most of and you can do these things as well. You see, you can have this thing and this thing here, right? So you can have soft zones. Good. Let's see. So it's basically, it allows you to go in that direction, but it's also it's softer. Yeah. Good. This is a simple look at. So again, we assigned the follow and the look at, and at the body we do nothing, and at the aim we use the composer, and we change the dead zone, right? That's what we changed. Yeah, we changed the dead zone. Because if this is 0, it will always move just a bit. You see, it moves. So it tries to always frame it in the middle, right? I have to see. Okay. Yeah, and that's how it works. And I think you don't even need to assign this thing if you are not following, actually. You're only aiming at it. So you don't need to assign the follow one. Yeah, I don't need to assign the follow one. Because you're not following it in Cinemachine's terminology. Following it means moving towards it. Good. That's look at simple. And let's see what's next. Follow cam simple. So here the camera is actually following the project, the player. And let's see, here we are not aiming at it. So look at it's none here because we're not aiming at it. And it has an exclamation point because it actually it had to be like this so that we are explicitly not aiming at it. We are only moving. And we're using this framing transposer, right? So, and I don't know what are the default values. Let's reset it. Or maybe can I reset this? No, I cannot. Okay. Transitions. Follow. Okay, but where's okay the body? Okay, the transposer, and let's see what differences do we have here. No difference. Okay, so there's no difference. No, only this thing, vertical field of view and stuff. Yeah, I changed that. I don't know how I changed that, but anyway. Basically, we have a field of view and stuff like that. And when you switch from camera to camera, one can have some field of view and another one can have another field of view. And basically, when it's changing from camera to camera, it takes 2 seconds to go from one state to another, and it smoothly goes to it. So, and it will go like this slowly, right? It won't go like this, right? Instantly, right? Unless you want it to. And the default one, the default duration is here in cinemachine brain default blend, 2 seconds. And this is even the function for it, and it can be custom, and yeah, you can create a curve here and how the transition curve should be. And yeah, this is a simple one. It just moves the camera. And again, this is more advanced than our camera, which we've created for the platformer prototype we've created, because you see it's pretty smooth. It goes like this, and you don't have to code that smoothness. It's already in the cinemachine. See, so it moves with you, and yeah, of course you can go here and body, and you can do this. Oops, yeah, you can do it like this, so it always stays in this part of the screen. You see, maybe you're telling a story, and then something happens now to the right. Something happens to the right. So basically, the player is moving. Something happens to the right. Now something happens to the left. But the player is still moving, is running. Something happens, and then again you move it like this, and yeah, we're just yeah. uh, um, yeah, let's actually increase the dead zone, right? Yeah, so it can move freely. You don't have to move the camera always. Okay, that's the simple example. Let's now look at the free look. Free look. So free look, again, the same options there. And the free look, you create a free look like this, cinemachine, free look camera. And let's see what I've done here differently. Only assign the player. Let's see, maybe not only that. Okay. Yeah, oh, I think I didn't even change anything. It's just the same, is the default values. Transitions, no. Okay. the default values. Good. Free look camera, and the way it works, it will, yeah, you can look around your object, like in, you see, and of course you can play with sensitivity and all of that, and you can look over it, and it works better if you're on full screen. And I don't know if this is full screen. I saw that when you build the game, like you're actually playing the executable, it works fine. So you see, it works like I don't know, GTA San Andreas or other games like that, right? That were uh, I think most games are like this now, right? Where it gives you the option to look wherever you want. You're going like inside the screen, and you can even like you can look around your. So for example, I'm pressing W. So I'm pressing, let's say I'm pressing, it's inverted for some reason. I don't know. You can just tweak it in the inspector. So I'm pressing W and it goes inside the screen, right? And if I'm looking like this and I'm pressing W, it goes like this, right? And of course you can play with some animations so it will turn smoothly and so on, right? But it's too advanced for our case here. Yeah. And that's free look camera for you. Then free lock rotation to camera, and this is very similar to this because it uses the same thing. Okay, yeah, it uses the same thing, I'm pretty sure. Cinemachine, free look. Yeah, it uses the same thing. And I have this, or I don't have. Yeah, I have this prefab, which is the same as the player, with just this thing checked here. And I should have created like a variant of the player, but no, it's just separate prefab with this lock rotation to camera. And what this does, it always tries to lock the player's rotation to the camera. And now if we look, let me do it the full screen because it works better. See, and yeah, you have to play with the distance towards the player and also the sensitivity. Yeah, see. I think we have to use like late update, or I don't know. No, I don't think. Yeah, so it's the same thing. I press W and I'm moving towards the screen. W, W, you see? So I'm not changing the global Z position, but the Z position in the camera space, right? And I'm pressing S, I'm going back to the screen. Yeah, and it's this thing like you have to tweak it a bit, right? Because if it goes like this, I mean, if you probably wanted to just go like still to have the face in that direction, right? And in the like if you had the real a real player animated here, you basically it would take steps down, steps. It would do back steps, right? How you mentioned it would take steps back, right? Not like this. Yeah, but that's basically it. So you aim and you do it like this. Okay. And you can look at this thing, so you can add an extension to the free look. So you have, for example, some collider, which means that if there's a wall and you move the camera will not enter the wall. It will collide the wall and it will just go near the wall like this, right? Because that's a very common issue in games. And where is it? There was something here for aiming. Cinemachine. it was something for aiming, which means it will show you a crosshair on the screen, if I remember correctly. And yeah, that would actually move basically for first-person shooters. Good. So this is it. And yeah, now let's talk about transitions, which it's a bit different, but it's pretty simple and it's nice to see. So a nice thing if you have played Prince of Persia, a lot of the classical Prince of Persia. There's a lot of them. You were walking, running, whatever, and there were a lot of cameras that were switching, right? From time to time, they were switching, and oh, there. Yeah, and that's basically what we will do here, right? And so the way it works, so let's say like this is the game, okay, and I think you cannot see it. Yeah, you cannot. Well, actually, let's do it like this. So you are here, and like if I disable this, basically whatever the camera is, or actually no, in the way it will work, it will be like this. You can either disable them or set them a priority. And if this is the priority 11 or 12, whatever, this is the active camera now. And then 13, this is the camera now. And then 14, this is the camera now. And then 15, this is the camera, right? And for that, in order to make it automatic, and of course it needs a lot of tweaking based on your environment. And yeah, so the cylinder is just this thing, it doesn't matter, it's just okay. And we have 4 cameras. We have 4 cameras, so this camera, this one, and this one. And I added a sphere to each of them so we can see them. For example, I mean, you don't see them here because it's this cinemachine icon, but yeah, you see them there, right? Yeah, and they are all just virtual cameras, and you have this follow and look at, but you don't need to follow actually, like I said, because you're not following. You're just looking at this point. And yeah, with aim, you might want to increase the dead zone or whatever, right? Yeah, okay. And you can see it like this. So if you set the aim here, the look at here, you have the camera, and when you move it, the camera looks at the player, right? This is a nice thing about. So it works in edit mode as well, where we are here, not only in play mode. I mean, it works like it does the minimum amount of things that for it to work. Just so yeah, it looks at the target. Good, but the action is in the game, and I can show you the cinemachine cam switch by. Oops, I thought I just okay. Let's open the lights. The lights. Whoa, that's some lights. Good. So we have this script here. So this script, we just attached it. We can attach it anywhere. We attach it to the camera because it's kind of makes sense. But it doesn't matter where you attach it because it here you assign it cinemachine virtual camera. This is the component. This is one. We pass it the list of them, and we pass it the target. And the way it works, it goes through all of the virtual cameras once per frame, so very often, and checks, okay, what's the closest camera? What's the camera that's closest to the player? And then it activates it. And the activate function, it just goes through all of the cameras, and it sets the priority 10 to the camera to activate, or 0 to the other ones, right? And I don't know, it just goes through all the cams. It goes, okay, distance from the target position, and vcam transform that position. And if the distance is smaller than the shortest one, which is initially the maximum value, it's like a few billions. So that's how basically this is a very simple algorithm for like seeing what item has the biggest value or smallest value for something. In this case, the smallest value, right? So you have this thing, which is the maximum possible value. And then, okay, if the distance, whatever, is smaller than this, which will be always true, we consider, okay, the first object. So the first camera is the one that's the closest, right? So it assumes like, okay, maybe the first is the closest. Then it goes again, and if it looks okay, take the distance, and it stores, right, the real distance for the last camera. And now it goes to the second camera, like I said, gets the distance and says, okay, is the newer distance, like for the second camera, smaller than the distance in the previous camera? And yeah, let's say it is. Then okay, now the shortest distance is this one, and the closest camera is this one. And now it goes to the third camera and looks, okay, the distance towards the third camera, is the distance for the third camera smaller than the shortest distance so far? No, it's not. Then we don't do anything. And then if it's the last one, then this one exits. And then we go, okay, if this one is not null, which should never be, this should never be, because if this is not 0, this will never be null. It will never be null. Yeah, it will never be null. And then we activate the camera. And that's what it does. So we set it here, right? Cameras. So the way you do it, you lock it, then you select these things, and then can edit them here. Bam, and it added them, right? And I Control Z because I already added them. And the target, which is the player's transform. Right. So let's start again. Let's see how it does. I mean, let's maybe make this bigger. So you see, the camera looks towards me, right? And now I just changed into the other camera. And because our script takes the current active camera, which is the camera main, I mean, in our case, we always have one camera only, and these things change these cameras' properties in real time. We're doing this like we're getting the transform, so we're getting like when we press W, we press whatever is the direction inside the screen for the current camera's perspective. So so I press W, I am going in that direction, right? But let's say now maybe the camera will change. Now W is in that direction. Well, let me go back now. And of course, you might have to put more cameras and stuff like that. Okay, now W is in that direction. Now W is in that direction. See? And yeah, like it really depends on your I don't remember how it was like in Prince of Persia or other games like this, but they definitely had it polished a lot, right? Yeah. And of course, now each camera can have a different depth of field, and I don't know what this does, but maybe someone is like a cameraman, knows all of these terms here. There's a lot of terms here. But yeah, let's add like a very high depth of field, and let's see which one is it. You see, this one is with the high depth of field, and you see it. Yeah, you can enter the wall. And now this is with the normal depth of field. Yeah, and you can interpolate. That's the term. Interpolate. You can interpolate between a lot of things. And you see, this is like the safe zone, and the safe zone maybe might change here if you want other cameras to have other safe zone. And it's a simple script. I mean, man, it's just a few lines. I mean, it's not that long. It's not even 50 lines of code. You just activate the camera that's closest to the player, right? And you can just ask ChatGPT, right? You ask it uh, something like this, right? Cinemachine enable camera closest to player, right? And it gives you um, yeah, basically I asked ChatGPT for that, and then I spent maybe 10 more minutes to make it work. Yeah, anyway, right. It will give you, or yeah, people now use Claude, but yeah, this thing changes so fast that if you're seeing this in 1 year, then you might be asking yourself, what? You were programming by hand then? No, I think like there are so many possibilities that you just cannot automate these things. And games are the hardest to automate in my opinion, because it's not like a website, and that's hard as well. But like a game has like sounds and all of that, and the artistic space is much greater space of possibilities. Um, yeah, but in order to verify LLMs, you need to know programming, because if nobody knows programming, then you might say, okay, we'll train LLMs to verify other LLMs, but then who verifies them? And it's this recursive dilemma, which we also have in politics since the beginning of time, right? Who will check the fact checkers, and who will check those that check fact checkers, and so on. Yeah. Anyway, um, so I don't think programming will ever disappear, because just it's impossible, right? Um, okay, this is Cinemachine. So I don't know if I should I just save it, or I don't know what did I. Good. This is transitions, and we are kind of done, I think. Yeah, we'll have some debugging we can do. Yeah, let me show you some debugging. So we've seen briefly that before, but yeah, let's just where is it, like the player, right? So let's say maybe the player, I don't know, doesn't move, right, or something like that. So maybe I don't know, is this the player? Yeah, player controller. And this is where we are getting the thing. And let's say we kind of did the copy paste, and this is how we're moving, right? And we don't know why, and we just press up, down, it doesn't work. So basically we are pressing A and D, and it goes like this, and we say, man, what is this? And I press W and S, and it doesn't work. And you basically go on Unity, and you have this attached to Unity. And if you're on Windows, you have to go like debug. Unity has more on Visual Studio, not Visual Studio Code, but also Visual Studio Code. But we're talking about Visual Studio here. It has more options on Windows. We basically go to debug and attach debugger to Unity, whatever. There are more options to attach. For example, attach to process, and yeah, you can also like if you have a standalone build running, like an exe that runs, you can attach like that, and you can also attach it to an Android device and onto an iOS device. But we won't go into that here. You can just Google it. Attach to Unity. Attach to Unity and play in case it's not playing. Let's see. Does it work with attach Unity and play? C# debugger attached. Enable debugging for this session. No, okay, yeah. Before the it didn't ask you that. So okay, I have to play because it reloaded some stuff. Okay, so I'm pressing A and D. Okay, let's say I want to. This is a breakpoint. You set a breakpoint, and you can also right click and can go edit breakpoint, and you can do something like and the following condition is true. For example, you can do like okay, it doesn't work, or maybe it works, but let's see if this works. Apply, and it already hit it, but let's press F5. F5 is just let's see, it was like this space. Yeah, it hit it. So when I press space, basically, but it doesn't have autocomplete. That's the problem. You have to write it here first to see that okay, it works fine. And then you go here and edit. And when input.getKey down is space, then whatever. But most often you do like, okay, if a certain variable, yeah, let's say that I might move this thing here, unenable, anyway, here. If move per second, this is okay. If move vertical, yeah, I don't know, it was like control space on Windows, but anyway. Move vertical is bigger than 0 or something like that, okay? And then this will only hit when it's greater than 0. So it hit it, right? When I pressed D, which is the horizontal, which means, yeah, it went. So it basically gets the horizontal and the horizontal for both up and down. And then that's why it goes diagonally. Yeah, that's the conditional breakpoint. But let's say, actually, that was a good check breakpoint here. So it's when either move horizontal is not 0 or is not 0, okay? Because this is called each frame, and then it means our breakpoint would just enter each frame, or at least it will always enter next frame, but we only want it to enter when there is some movement, right? So let's move, and yeah, it hit. The problem on Mac and on this VS, yes, Visual Studio, is it doesn't switch automatically to the Visual Studio when the breakpoint is hit. Okay. Yeah, so at least one of these things are not 0. So let's see. We hover over this one is 0.02. This is move vertical is 0.02. And they are the same value. And then I see, oh, okay, I just forgot to put this vertical here, right? Vertical, whatever, right? But of course, you can go like inside the functions, you know, that like if this function calls another function, you can go into that, right? Let's say like you press F5 and you have these things here like continue. This is for continue debugging. This for restart, but you don't really. I mean, yeah, you can restart debugging. You can step over. Step over is this, like just go to the next one, which is F10, I think. F10, yes. And then you have like step in, which means you go inside this property and see what is there. Let's see if we can. No, you cannot. You can step in, but I don't remember how. And like I said, Visual Studio seems a bit limited on Mac. Good. Let's just press F5 and just, yeah, the next frame has already started, right? So it hit this one. And we go step into, if we don't do go, if we won't do step into, it will just go over it like it already executed it, right? Press F5. I don't know why it reloads the domain. This shouldn't happen. But anyway, maybe just it thought it's reloading. Anyway, yeah, so we're in the next frame. Now we go step into, which is F11 or this thing. Okay, F11 on Mac. Okay, wants to do something else. Step into. Now we're inside the move, right? Then F10, F10. This was false, so it didn't enter here. Then bam, bam, bam. Nothing was pressed, so the magnitude is smaller than 0.1, so it returns. Bam. That's what return does. It basically returns the function, or you can say that it skips everything and it goes right to the end. Yeah, you can say that as well. Yeah, that's how it works. So this is not a very in-depth debugging, but just I give you a taste of it so you can know that it exists. And if you want to understand why certain things happen, just use debugging. And there's a tendency to not use it. I don't know, at least at the beginning. I really encourage you to use it a lot, like a lot. If just something takes you more than a minute to solve, just use debugging, or you might even use it right away. Good. Yeah, that's just like I said, a glimpse into debugging, and yeah, and there's also like console debugging. Console debugging, it's a more primitive way of debugging. Not primitive, but it's a simpler way of debugging, in the sense that let's say you want to build on your device and you have there's a thing on Android devices log, it's called logcat. Basically you can see the logs on your device on the desktop, and you can also do it for iOS. They have their own thing. And maybe let's say you cannot attach a debugger because it's harder, or I don't know, something like that. You just do things like this, right? So debug.log locking or whatever, right? And you can also add the game object. So the game object is a property that any mono behavior has access to, and it references the object that the mono behavior is attached to, right? So you have like locking, and yeah, this is how it works. So a log can also optionally take an object, and it can take an object, which means it can also take a reference to an asset. For example, you can drag a thing like this right here, and you add it as a context for the debug log, and then when you press the debug log in the console, oh, I have to stop debugging, right? Stop debugging. Just, yeah, it's easier. And when you press the thing here, let's see, controller, no force. Oh, okay. You see it highlights this, but if it was an asset here, like a prefab, it would have highlighted it here. So it depends on what you want, right? But it gives you context, because if you have hundreds of messages here or hundreds of objects here, even if it's one message, you don't know what object that message is being triggered by. Yeah, who that message is triggered by. Yeah, and that's how you do it. So you would have a lot of logs, and it's like the simplest way in which you can debug stuff. Like, let's say, move per second, and you can do it like this. Right. Oh, okay, so when you move, you get like the speed here, you see? Move per sec, it's minus 18. You see the Y position is always 0, because we don't change. Yeah, I think this is how games work, because I knew always when the camera changes, my controls always had to change. So if I was going on a W and the camera changed, at some point I had to just adjust and like press maybe W and D, and or W and A, and so on. Yeah, so yeah, this is how you debug stuff. Just a glimpse. And yeah, that's it. That's it for today. Um, so I will just briefly talk about the project. So you guys signed up. So a lot of you signed up and confirmed that they will attend the course. But I see that very few of you actually attended. So yeah, it doesn't matter. This is the course that I'm recording, like, for to basically have the recorded version of it, and now I can help anyone, and it's free and everything. But yeah, like I was saying, there was a spreadsheet with the presence where you guys added what games you would want to create. And I see there are 2 platformers. So what I will do, I will just give you a brief of how a game design document should look like. And we've done that before, and I will do it now again, just briefly. And you will have to basically create your own game design document of 1 page. And yeah, start messing with Unity, just trying things, even if you don't know everything. Just be active there in Discord if you want, right? I mean, just be active there and ask me stuff. So I won't be here always, so it's just as part of this course. Yeah, I don't know after this course if I will immediately go and teach it in another place or not. Because yeah, the initial plan was to teach it in Bucharest in real life, and then go into other places. But since it's remote, I'll keep it as it is. And yeah, I also like do it in person when if I will have a lot of confirmations in other countries. Yeah, we'll see about that. But yeah, I don't know what I should say. But basically, it's this step currently where I will just show you a game design document, and you will create your own, and you will be creating this game that it shouldn't take more than maybe a week, with like 2 hours per day or something like that. Yeah, and just ask stuff, and on Discord, ask here, um, and what will follow tomorrow, the day after, and the day after, I will be live coding a game which won't be a platformer, but will be a duck invader, basically. And we'll do 1 hour of co-working after each session, actually. So, and today I'll be basically taking the game design document for the duck invaders, and I will make a smaller version of it, and that will be like maybe the first hour of co-working. Yeah, and basically that's what you will have to do with a platformer. And just ask anything. Just ask anything, like, I don't know where to start, or I don't know what Unity version to install, but also like I hope you installed it until now. But yeah, and I will try to help with whatever I can in these days. So I will be live coding the Duck Invaders, and then just 1 hour of co-working where I will still be coding Duck Invaders, but when it will be more low key, so I will be able to help more than do my thing. And yeah, we'll have this 3 days. So the following 3 days would be just coding, and I will try to also explain stuff while I'm coding, but it will be like 80% coding, 20% explaining. And yeah, like I said, on day 5 we'll talk about these things, and then less code in the next week, and more about the non-coding part. Yeah, and during these 3 days you would be able to see like the whole process. So yeah, you should learn quite a lot from that. Yeah, let me, yeah, I will ask, just all of you, I'll ask privately, like, okay, will you still be creating a project, or will you need anything from me to create a project? I mean, for a 2D platformer, since this is like the two of you guys ask for it, I mean, you'd create a game design. I mean, yeah, let me actually pull up that. Where is it? Duck Invaders game design document. So it's this thing which is really, really big. I don't know if I should annotate this or just create a new one. Okay, the last version is here. Yeah, so this is the game design document, but let's go quickly through it for your own game design document, or even what I will create for mine. You know what? Let's actually create one. File, copy. Minimal version. Good. And let's say this thing. Let's say scope, platforms. Okay, here's the latest version, but I don't know why. Let's see. Last updated June 3rd, 2022. Wow. You see, I've been working on this thing for a long time for this course, but it's like just 4 weeks. It feels like nothing, but trust me. I mean, it's not actually only the course; it's actually the platform for the courses. But yeah. So June of 2022, and file history March. So it feels like this is the latest one. Yeah. Anyway, let's just go with it. So minimal version inspired from whatever. Yeah. Story. Yeah. I mean, the story, you can just write this as a message at the beginning, right? Text, just text on a UI, right? Platforms. Let's make it a single platform. Let's make it for Android. And let's make it for WebGL. Yeah, this is a nice thing, because if you have a WebGL thing, you just send someone a link and they can immediately play it. And on mobile, it doesn't really work that well, but it works on PC. Maybe they fixed it. Because on mobile, you have apps, so you built it directly. And we'll be doing WebGL and Android. And we have UIs, okay, mobile and desktop. Mobile, we just press. Okay. UI folder. Is there a UI? I don't actually understand. Maybe there's some assets somewhere. Anyway, I'll just keep this here. Transitions that need a loading screen from main menu to game and back. Okay, we won't be making a transition. Should be done within the same scene, main menu. Okay, so basically we won't have a scene, a separate scene. We'll have just the same scene with some just overlay, some black image with some text on it. Okay. Settings, we won't have settings. Main menu level selection. Oh, okay, I see. From the main menu to the level. Oh, okay, so here we won't have. We'll be into the same scene. We'll have the same scene. Actually, no. Let's just do settings, because it will be easy. It will be just a thing. Entities. Okay, we have the player, a spaceship. Player damaging projectiles will be an egg, regular white. Homing, green glowing egg that comes after you. And HP infinite impact damage. In 3 days, 3 hours per day. I think touch effect, 1 HP per second drain for 10 seconds. I like this quite a lot. The dark one, I think I should remove the dark one, I think. Just to have like a minimal version. Regular white. Or actually, you know what? Let's make this optional. Just this is optional. No, optional. That thing is optional. Then enemies. Duck, yellow, green, blue. Oh, this is too much. No. Okay, and I think I have like bosses per level 1. Okay. Mechanics, and I have waves. Okay, I also thought about waves. Man, I think this thing can be doable. Like you create waves. Uh bosses per level. Let's have 2 levels only. Or you know what? Let's have like 1 level, and these things will be optional, just so we can make sure we will be making these things. So, and we have a giant duck. Okay, we are also like describing it. Good. So player damaging projectiles. Egg. So it's a regular white. Then enemies yellow, green, blue, red, dark, and overgrown duck. Okay. And mechanics. Projectile type. You have a laser, which is the default one. Area bullet. Average damage, but more area of effect. And we will be having laser as optional. So if we will have time. So yeah, there's a thing with somewhere. Okay, I'll take a look at this. Enemies have random chance of dropping weapon types and weapon upgrades. Okay. Each level consists of some waves of enemies, and ending with a boss. There are no fixed rules in terms of how many waves and how many bosses and mini bosses there are. Level designers should be able to combine them freely. Well, this is just too much. Progression. We have level 1, wave, yellow duck, green duck, blue duck, overgrown in the middle, boss. And let's keep it like that for now with only 1 level, right? Just under promising and over delivering, or at least trying to over deliver. Okay. So again, I'm talking about the game that I will be coding from scratch in the following 3 days, but you guys will be working on your 2D platform, and just I don't know how you take your inspiration, but you can just look at YouTube and see other platformers and try to create a version that's 10 times simpler. And I wouldn't focus that much on the animation of a player or something like that. You just use cubes and the capsule collider, and just maybe look into the character controller component. There's a thing called character controller, but we've already made a good enough character controller using the rigid body and the animator and stuff. So I mean, in terms of code, not in terms of, and you can get it, yeah, through the repo, to this repository that's attached to the course, right? You can find the controller there. I mean the 2D one, right? When I briefly like kind of I've made the starting of a platformer there. So yeah, you can take that one, or you can just try to understand it, like create it from scratch. Um, yeah, and use cubes, and like for power ups or points, just use another cubes that are colored differently, and you can make them spin if you want. Like, it's not that hard. Don't be afraid to use ChatGPT. It will be a great help for small stuff like that. Then I mean, I not even I spend the time to write stuff like that, like 80 lines of code for spinning, or for a script that spins an object, right? Just ask ChatGPT for that. I mean, um, yeah, okay. Yeah, we'll be making just one level, and also we want an ending screen with 3D credits scrolling like on Lucasfilms style. Um, okay, screen transition between major scenes, fade in, load resources, fade out load resources, fade in. When a level starts, the screen fades in, the spaceship's engines fire stronger as it charges for 5 seconds, visualized by 10x faster scrolling background, because yeah, you're actually not moving, you're just staying and the background moves, right? That's one of the oldest tricks. Um, then slowly coming to the normal speed. Slowly scrolling background with stars, galaxies. Multiple feathers spawn at random on hitting a duck. Yeah, this is like a particle system, right? Uh, Regular ducks explode with no fire, just a poof. Other ducks explode with a size proportional to their own size. Let's make this optional. Spaceship explodes as an overground duck, but I don't know how that explodes. How does that explode? Egg type, dark, spread circular across the boss. I don't know how does spaceship explodes as an overgrown duck. I don't know what this is, so I'll just be marking it like this. um Boss HP bar always at the top. Okay, yeah. 1 HP bar per boss stacked horizontally and scaled down appropriately if there's more than one. Optional. When a level ends after the boss, soundtrack stops for 3 seconds. Then soundtrack 4 plays and the ship takes over and flies out of the screen. Level fades out. Yeah, there's definitely a folder somewhere with stuff. This is a support project for... Okay. Okay, yeah, I will. Anyway, doesn't matter. This is not something you should care about. It's mostly for me. Good. Sound, screen effects, soundtrack during menus. Okay, boss is destroying a boss. Sound effects. Yeah, let's make this optional. I mean, I'm sure we will have them, but optional. Not possible to have monetization, I think, in 3 days. But who knows? Now it's more doable. Now it's more doable. So yeah, like it's already too much for you. So yours should be even smaller. Like these things, probably like remove 3 of them, right, or something like that. Because I only have one level: yellow, green, blue, overgrown. Yellow, green, blue, overgrown. So basically, these things are optional as well. Good. And this is my game design document for Duck Invaders. And I will be following this. And yeah, I mean, if you are still here, guys, with the platformer, I can just show you some things for the platformer, just briefly. If you remember correctly, no, if you remember, not correctly, if you remember, we've made something like this. So, I mean, just keep it simple, right? I mean, I had the tendency to just create like a level editor or whatever. No, just create like this. So level 1, 3D cube, double click it so you see it, and you can press this 2D right here if you want, but I don't know, it depends. I really like to have the option to always turn to 3D if I want. So I'm creating like 3D stuff. Cube, right? And you press T for direct transform and you do it like this, right? And this is like your platform for whatever, like this. And then you move. And again, like I told you this shortcuts. So with mouse 3, so the wheel, you press it, right? You with the wheel you zoom in, zoom out, or with Alt and right click Alt or Option on Mac. Right click, do it like this. And if you do it with Shift, so like this, and you press Shift, it does it faster. Okay. And then with the option, let's put this back to perspective mode. Option or Alt again in left click. So Alt, left click, do it like this. And if you want to center your object, you double click it. And now you're orbiting at exactly its center, right? I know, like I've already mentioned these things, but I don't know, let's, okay, cube. And you can call it like platform. And you know what? Let's make it like 10. 1. Yeah. And let's make like, you can make prefabs, man. So platform 10, 10x1. And just make prefabs like this, right? I mean, you can create like, you create a folder. So world. I mean, don't do this. I just do it as a trick because it's alphabetically sorted, so I can have it here, right? Yeah, and this is your platform, and then let's say you're doing, you want maybe I don't know, 10 by 2, or I mean, it really depends on what you want, or what you see that you need, right? And then you do it like this, and you original prefab, because it's not a variant of it, it's original prefab. And yeah, you just can create as many things as you want. So one can be like water, and you create material for water. And yeah, you have to see how would that work. But I mean, you can go like in legacy shaders for very simple. Was it this one? Yeah, I mean, you can just, and you can have like yeah, you can have like water if you want. Or it can be like, right, you give it the water material. And then you also put it like this, original prefab. And yeah, then you can add things like this. And then you also like have water. Or maybe you can have it like this. And I mean, yeah, you can make the water like this. slightly on Z, like 0.9, so that it enters inside the, you see, like this. And it doesn't need to be perfect. I mean, it doesn't need to be perfectly, I mean, it needs to be, I mean, let's put the 0, position Z 0. But they inside themselves don't need to be like perfect, right? Like this, and the player has to jump over that thing, and it has like a power up, 3D like effects, yeah, 3D sphere, or let's make it a cube, so you can make it spin, right, like this, whatever. You can make it spin like this, right? And it's global here, that's why I can do it like this, because if it would have been local, I can only like see. Yeah, like power up, not power up, but coin or whatever, right? And you added like a particle system, right? And distance, or what was the, I don't remember what it was, like distance, right? Or emission, shape, emission, rate over time. Yeah, you can, you know, yeah, you can play with it a lot, right? Like that's your power up, basically, your coin, actually, right? That's the material water. This is a coin, and of course it needs a collider, but it's a trigger, so that and we have to apply this, apply to prefab, right? So it applies it to this. It's a trigger, so you have that on trigger enter, so that your player doesn't collide with it, right? And it falls down. It has that on trigger enter, which we talked about in the physics session. Let's see if there's anyone here that asks anything. Okay, nothing. Yeah, and this is your platformer. Like you can just create stuff. You put your player here, and you see how we've made the movement of a 2D player. And yeah, you have a trigger. Like you can have, let's say, a 3D object, which is a. I mean, let's just copy this over, and just like this is level end trigger, and this trigger, and this I'm lazy, so I'm just copying this thing. Level end material, and you have, let's see, can you have, no, you cannot have transparent. Legacy transparent, diffuse, vertex lit. This is the most efficient one. The most efficient one. So yeah, this is your level end trigger. I don't know if you do you see it. It's like there, and level end. Yeah, and I mean you can just make it. You can make it like this, whatever. You can make it invisible if you want, right? Or you can just disable this thing or whatever. Yeah, this is your level end trigger. original prefab because we want it to be like to not have any ties with these things. Yeah, and you can add here a script which it's on trigger enter. It basically shows you've just completed the level or whatever, right? So then that's your like level end, right? And yeah, your level can be just, you know, whatever. You can make your level, you can go you know, over these things. Like you can have a platform which is 10 by, I don't know, 10 by 5, right? Then you have like 5 here and 10 by 5, right? And that's like your thing there. And you can create some enemies if you want, and you can like collide with them. And when you collide with them, you basically die or whatever, right? And just, yeah, keep it simple like this. Like you create the stuff. You don't need like a platformer pack or platformer creator asset, ultimate, whatever, because it takes a lot of time to learn that thing. And for just learning how to code, just or learning how to use Unity, just do it yourself like this, right? Because if you're using those things, you're learning how to use those things. You're not learning how to use Unity. But there are good assets there. I know there are good assets and there are good packages that are builders and stuff like that allows you to build. And there's also I don't know how it's called, Pro Builder, I think. I don't know if it's still like the best one, but it's a thing that allows you to build your own things. Like you basically can take this corner and put it like this, and not only, you know, not only the edge, but also I can take the corner and with the corner only have like a slope and you know, lots of those things. And yeah, like you can put your guy here and you jump over things, and here in the water, like I don't know, yeah, water. Maybe your guy is afraid of water or something like that, or he drowns. I don't know. And then you have like you have to do them like this, right? If you want to, yeah, it looks more legit this way. Looks more legit. Yeah. Yeah, so this is like my hint for how you can make a platformer. Great. So this was it for today. And yeah, if there are no questions, I'll see you tomorrow. I'll see you tomorrow for the live coding sessions, the beginning of the first live coding session. Yeah. See you. See you tomorrow.